some different types of angles, and then we're going to find the measure of some angles as well. The good thing is that on most angles, you're not going to have to measure, okay? It's one of those, like, we don't do a whole lot of measuring angles. Anybody ever seen one of these before? Okay, may know what it's called? Yeah?
Is it a protractor?
You got it. It's a protractor, okay? And this is kind of a big teacher version of it, okay? They make a lot of smaller hand version of it where you can put it on a piece of paper and find the measure of an angle. But essentially, if I had an angle up here, we have a point right here that's called the vertex, okay? And what we would do then is we would slap this up here, okay? And there's a little jot right here in the middle, and that's what goes on the vertex. And then you line the bottom edge up with that bottom ray, okay? And then we look up here, and there's two numbers, okay? One number is 50, the other number is 130. That's because sometimes we have what we call an acute angle, and sometimes we have what we call an obtuse angle. In this case, we have a small angle, so it would be the smaller of the two. And so we would say that that angle would be about 50 degrees, okay? It's a tool that we can use to measure angles. We won't be using protractors a whole lot. We used to always have kids get a protractor at the beginning of the year, and we use it in geometry, but like we would use it like once or twice, and then we really wouldn't use it the rest of the year. So we had you guys stop buying them just because, not that they're super expensive, but it wasn't something that we used a whole lot. Okay, so what makes up an angle? Well, kind of like the one I just drew up on the board. We have two rays that share the same endpoint. So on this one, I would say ray BA and ray BC. Remember, on a ray, we start with the endpoint. So BA, BC. And the order does matter for that. So ray, BA, and BC are the sides of the ray. Okay? Those are the two that form the angle. And then they form an angle between those two rays. So this is the angle that we're going to be referring to a lot when we talk about that angle. Sometimes it's a really big angle, sometimes it's going to be a really small angle. There's a lot of different types of angles that we're going to talk about. In this case, B would be my vertex because that's the point where the two rays meet one another. Okay, it's the shared point, however you want to think of it. So B is what we call the vertex. We'll use that word a lot. We already talked about the sides. The rays are the sides. I probably should have wrote that down here instead of where I did, but same thing. BA and BC are your two rays. And then ways to name an angle. Well, there's a lot of different ways to name an angle, and that's what you're going to kind of start finding out about geometry. We already have found that out. There's a lot of different ways to name it, depending on the type of figure that we have. Okay, the first way is you can simply name it off its vertex, angle B. If there's only one angle at that vertex. If there is more than one angle at angle B, then I can't call it angle B because I don't know which angle I'm talking about. And I'll show you some examples of that. Bless you. I could also use three letters, A, B, C, or angle C, B, A. Okay, but one thing you'll want to notice about this, the vertex must be in the middle. So I can't say BAC or CAB, okay? The vertex has to be in the middle. In this case, that's B, so B has to be in the middle. Because it's the vertex, it's the middle of that angle. And then finally, sometimes you'll have a little number in here. Like I might put a 1 in here, and I could call it angle 1. it doesn't tell me the angle measure, it just is a way to describe it or name the angle. The reason we would use that sometimes is we're going to see pictures sometimes where we may have like 10 different angles on it. And so I'm going to ask you to find the measure of all 10 angles. And they're going to be labeled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And then you'll have to find each angle individually. Find the measure of it. Okay. I told you earlier, sometimes we put these on our notes, just some common things to think about or common errors that get made. When a point is the vertex of more than one angle, you cannot use the vertex alone to name the angle, okay? And that's an example of what's going on right here. Okay, the vertex is F. We can't call that angle angle F because which angle F are we talking about? We actually have 3 of them. I could say EFG, that would be an angle, right? I could say GFH, which would be the bottom half, that would be an angle. Or I could even do EFH, which would be the big angle, those two together, okay? So there's 3 angle Fs here, and if I said angle F, I have no idea which one you're talking about, okay? So if there's more than one, the one up above, that was it. B was the only angle at B, right? So we know which angle you're talking about. Down here, we don't. So that's where you got to be really, really careful. Okay, so the 3 angles in this diagram, I kind of just mentioned them, but we'll talk about it. Angle E, F, G. That would be like the top one. You're just following the path. Okay, now here's my question for you. Would it be okay if I called it GFE? What do you guys think? That'd be okay. Okay, order matters, but as long as F's in the middle. EFG and GFE would be the same thing. So one person could call it EFG, somebody else could call it GFE, and we'd be talking about the same thing. Okay? Same thing for the bottom one down here. The bottom one, GFH or HFG. Either way. And notice I always put that angle symbol in front. Earlier in the chapter, we talked about segment symbols. We talked about rays and lines and planes and all of those symbols. Here, we have to have an angle in front. So we know we're talking about an angle, not a plane, because the plane also uses 3 letters. So if I just said GFH, that means we're talking about a plane, not an angle. And then finally, we have EFH. So those are all 3 different angles. They'd all have 3 different measures as well. Okay, and so, and they also all use F. F is in the middle of all 3. So that's another reason why, once again, we can't say F. Okay, try this one here. Try to name the 3 angles formed at the lighthouse. See if you can name this. I'll give you a couple seconds. All right, who wants to try one? Yeah.
Angle J and K.
Angle J and K. Okay, that's a good one. Okay. Second one? KML. Good. And finally, the last one? JML. Good. Okay. And once again, M is in the middle. They all share M, but they're all 3 different angles as well. Okay. And if you reversed the order, we'd still be okay. Okay. Which one does not belong? So we have 4 names here. We have angle 1. Angle 1 is going to be referring to the label of the angle that has 1. So it's this angle right here. What else could we call that? Could we call it angle A, we could, but that's not listed here. Can I call it BAC? Would that be okay? Yeah, because A's got to be in the middle, right? If we're talking about angle A, A's got to be in the middle. What about this third one? Is this one okay? No, what's wrong here? A's not in the middle. BCA is referring to this angle right here, where C is in the middle, okay? Last one, CAB, that's okay, because A is in the middle. So first, second, and fourth are all the same. The one that does not belong is the third one. Okay, I think you've probably heard of most of these angles before. These are the 4 types of angles that we're going to identify today. When we classify an angle, we're going to identify it as acute, obtuse, right, or straight. Straight might be the one that you maybe haven't heard of before, but we'll talk about that one. Okay, when we talk about an acute angle is anything that's between 0 and 90 degrees. And they say less than 90, but we do have a low end, right? We don't ever want to have negative angles, at least not in geometry. You get to trig, you can deal with some negative angles in some cases, but not in geometry. Okay, so that's good news. No negative angles. Okay, what does an acute angle look like? Well, it's kind of like the one I have up on the board. The two meet, and what's going to happen here is this ray is going to fall backwards and forwards, different directions. Okay, but if the two are fairly close together, then we have an acute angle. An obtuse angle is where my angle measure is somewhere between 90 and 180. Bigger than 90, but less than 180. An example of an obtuse angle would look like this. It falls backwards, kind of like you put your recliner back. Opens it up a little bit more. Okay, a right angle is going to be equal to 90. Okay, we talked about this yesterday, but what's the symbol that we use to show that we have a right angle? We saw it like on squares and rectangles yesterday. Yeah, it's just a little square, right? Just a little square in the corner. Okay? And so you're going to see this symbol a ton throughout the year. This little square in the corner tells me that we have a right angle. Okay? I don't even have to tell you that it's a right angle, but if I see that square on the picture, boom, we know immediately that that is a right angle. Okay? The fourth one here is a straight angle. Okay? And here I'm going to show you what a straight angle is going to look like. You're going to have a ray going this way, and then you're going to have an opposite ray going the other way. Okay? And what do those two form? Well, they form a line, a straight line. Okay? And so in order to be a straight angle, you have to have two opposite rays. Thank you. So it's two rays that are going opposite directions from one another. We saw the word opposite rays earlier in the chapter. Here we see it again. Okay, forms a line. Okay, I threw the protractor up there earlier. If we ever ask you to measure, there's going to be a protractor up on the screen, or I think Big Ideas might even have one that you can like pull onto the screen and then like rotate it a little bit. So there'll be one on the actual computer screen that you can use. So you shouldn't have to use your own protractor. It'll be provided in some shape or form. If it's on a test or a quiz, it would probably be a picture like this, where you have a picture and you have to identify the measure of that given angle. Okay. We already talked about how sometimes they have an inner and an outer scale. You got a small number, you got a big number. If it's a acute angle, we're going to use the smaller number. If it's an obtuse angle, then we're going to use the bigger number. Okay? GHK. So we're going to follow the path G, H, K. Okay, before I ever do anything here, I'm going to classify it. Classify it means what type of angle do we have. So out of the four that we just talked about up above, acute, obtuse, right, or straight, what do we got here? Obtuse. Okay, it falls backwards, right? And so this is an obtuse angle. Okay, and then it starts here and it goes here. So my angle is either going to be, it's between 50 and 60, so it's either 55 or 125. Well, if it's an obtuse angle, which number makes the most sense? The bigger one, right? 125 degrees. Because 55 would be an acute angle. Okay, so it's got to be one of those two, either 55 or 125. Okay, J, H, L. So let's go J. I'll use different colors here. HL. Okay, it starts down here and it goes straight up and down. How many degrees are we looking at there? 90 degrees. Okay, so because we're looking at 90 degrees, how are we going to classify it? A right triangle, or right angle. Okay, and then finally, L, H, K. So we're going to start at L, we're going to go to H, and we're going to go to K. So it would be that yellow angle right there. Okay, here's where you got to be a little bit careful because it doesn't come down here to the bottom, right? It's kind of sitting up here. So it goes from 90 all the way down to 55, right? So how far is it from 90 down to 55? How far have we gone? 35, okay? So we would do 90 minus 55 equals 35 degrees, which makes that an acute angle. Okay. So when you're looking at the angle, just follow the path, follow the three letters. The one thing that all of these had in common is they all had H as our vertex, right? H was the point that's in the middle, but we have a bunch of different angles going on there. So you got to make sure you follow the path so you know which one we're referring to. Okay. So we have a blank here, okay? We've seen this word before, and I told you it's a very, very common word that we're going to see a lot in geometry. If two things have the same measure, what's the word we're going to use for them? Congruent, okay? So that's what we're going to use here as well, okay? Two angles are congruent if they have the same measure. We saw it last week when we talked about segments. We said two segments were congruent. They had the same length, the same measure. Now we're going to do it with angles. If I draw two pictures here, hey, how you doing?
Great.
Good.
My name is A-R-I, and my back to my phone.
Thank you. Okay. When we did segments, with segments, we always did a little tick mark, right? And we said, okay, if this segment has the tick mark and this one has the tick mark, then these two were congruent. With an angle, it's a little curved marking in here. So this marking and this marking means that these two angles are the same. They're congruent. I don't even have to tell you what the angle measure is. Okay? We don't care necessarily what the angle measure is at this point. We just want to know, hey, if those two have the same mark, then they're congruent, right? Now, what would I call this angle here? What would be the easiest way to name it? It is acute, but here we're talking about like naming it. Hannah?
Angle A.
Angle A, okay? There's also, we could say BAC, CAB, but angle A would be the easiest because it's the only angle at angle A. The easiest way to name this one is angle S, right? And so what we're going to say here is that angle A And remember the symbol? Angle A is congruent to angle S. And there's that congruent symbol again. We did it with segments. Still use the same symbol for angles. It just means those two angles are exactly the same measure. Okay, going down here. Okay, sometimes we would do like one tick mark, right? Sometimes we did like a double tick mark when we did segments. Same thing for angles. We see this angle marking here, we see this angle marking down here, okay? Is it okay if I just call this one angle G? Probably not, okay? But there's no other letters labeled over here. There is more than one angle at angle G. So just to be safe, I probably would say angle HGF is congruent to angle, and then we're going to look at the one down here that has the same marking, right? And I could either go CBA or ABC. And we know those two are the same because of the marking, okay? We don't know the actual angle measure, but we don't have to. The other one that we see, this one has it's kind of like a double rainbow, right? We got a double marking here. So we're going to say angle EFG is congruent to angle ADC. Okay, you could do it with like 3 markings in there. If this one has 3 and this one has 3, then they'd be congruent. You could do it with as many as you want, but the more markings you have, then the more angles that could be congruent. Okay, if ADC is 140 degrees, then what is EFG? It's 140, right? What did we just say up here? We said they're congruent, right? And what does it mean to be congruent? Exactly the same, okay? Sometimes you look at this and you'll be like, oh, don't overthink it, guys, okay? Sometimes it's as simple as that. Because they're congruent, measure of angle EFG is 140 degrees. There's no work to be done. We're just identifying that they're congruent, so that means they're also. The one thing I will point out here is we have this little M right here, and that means measure. So when we put M there, we're talking about an angle measure. So we want our answer to be degrees of some kind. Okay. Another postulate. Earlier in the chapter, we saw what we called the segment addition postulate. If I had a big old segment, what we talked about was this piece plus this piece equals the whole thing, right? Guess what? Angles are exactly the same. This angle plus this angle equals the big angle, okay? So when we have 2 angles, and I'll show you an example here. RSP and PST equals RST. Okay, I don't know what the measure of these angles are going to be, but if I said this angle here is 30, and I told you that this angle here is 40 degrees, then the measure of the big one would be 70. You just have to add the 2 smaller ones together to get the big one. Okay? That's all there is to it. So we call that the angle addition postulate. When they have a ray that is shared in the middle, those 2 smaller angles together make the big one. Every time. Okay? If they're 2 completely different pictures, then we can't really do that. But because here they have that shared ray in the middle, then we can take a look at that. Okay, angle bisector is a ray that divides an angle into 2 congruent angles. Okay, are these two angles congruent? Not here, okay? Because we got one that's 30 and one that's 40. So this would not be an angle bisector, okay? But an angle bisector is going to look very, very similar. Okay, the picture is going to look very similar. Let's call this one L, M, Q, N. Okay, and if I simply just put those two markings in there, what's that mean about these two angles right here? What's that marking mean?
Equal 90 degrees.
Not 90. 90 would need to have a square. They're the same, right? We don't know the actual measure, but we know that these two are the same measure, whatever that is. Both 30, both 40, whatever, okay? So in this case, we're going to say angle LMQ is congruent to angle NMQ. And so we would say that MQ, ray MQ, is the angle bisector of angle LMN. And so what that means is it splits that angle right down the middle, bisects it. Bisects means cut in half. Okay? Sec means to cut, bi means to cut in two. Two equal parts. Okay, last thing here we're going to take a look at on the last page here is applying the angle addition postulate using some algebra. Okay, we did this with segments. It's going to be very, very similar. We're going to have a lot of different algebra skills that we're going to keep coming back to. Okay, solving equations is one of those. Okay, what would you say would be true about these two angles? Do we know if Km cuts them in half? Okay, and we don't want to guess. We don't want to say, oh, it looks like they're about the same. Okay, we don't know that for sure. It would have to tell us something. Or it would have to have a little angle marking here to show us that these two are the same, right? We don't know any of that. But what we do know is that the big angle is 145. So from here all the way over to here is 145 degrees, right? So what we can say is this small angle plus this small angle equals 145, okay? So here's how we're going to set this one up. 2x plus 10 plus 4x minus 3 equals 145. The two smaller angles added together equal the big one, okay? They didn't have this one labeled on the picture, but some of it's given to me in written out form, some of it's given to me in the picture, okay? So we're going to combine those two things together to put everything together into an equation. Now we got to solve, okay? What would be our first step to solve for here? What do we got to do first? Add like terms, good, okay? So 2x and 4x would make 6x. 10 plus negative 3, just really be careful of your signs. Signs are the things that throw us off probably more than anything else. 6x plus 7 equals 145. So we've kind of combined everything on the left-hand side together. Now it's just a two-step equation. Okay, my next step would be subtract 7. Yeah. 6x equals 138. And 138 divided by 6 gives me 23. Okay, now here's where you got to be careful. Okay, and we had this last week on some of the big ideas. Some of you guys were working the big ideas out, and you're like, Mr. Root, I put 23 in. I know it's right. It's not. It's telling me it's wrong. because the question doesn't say what is x. Sometimes it will say that. Sometimes it'll say what is x, right? And we're done. But this one doesn't say what is x. It says let's find the measures of those two angles, okay? So what do we got to do with 23? Got to plug it in, okay? Plug it in right here. 2 times 23 plus 10. So angle LKM equals 2 times 23 plus 10. And that would be 56 degrees. Okay. The other one it asks us to find is MKN. And that would be 4 times 23 minus 3. So those are just plugging it into your calculator and evaluating it. Okay, what's that give me? 89. Okay. Now, I will tell you this. Here's a great way for you guys to check this out. What should be true about these two angles?
Should equal 140.
You bet. If I add these two together, it better equal 145, right? Because that's what we just said. These two angles together make 145. Boom, they work. Everything goes together, okay? So that's where you want to check this out. Okay. Take a look at this picture and tell me what you notice on this next one. It doesn't give me a whole lot of information over here. They're the same, right? And we know they're the same because we see those two markings. Another thing that we know is it says the QR bisects it. So there's another piece of information we can use that said, here we go, QR goes right down the middle of it, right? Bisects means cut in half. So QS goes right down the middle. So that means if this is 24, what's the other half got to be? 24, you bet. Hey, except here, be careful for what we're looking for. We're looking for P, Q, R. We're looking for the big one. Well, how are we going to get there? Add them together, you bet. 24 plus 24. A little bit easier on that one. Not as much work. That's good. That's always good, right? Okay, last one. Key word here is straight angle. What does it mean to be a straight angle? It's one of our vocab words today. 180. You bet. So 180 degrees. So these two together make a straight line. They make 180. Okay? So this will look very, very similar to the one we did up above. Okay? I'm not going to work this whole thing out with you. I'm just going to show you how to set it up. 10x minus 5 plus 4x plus 3 equals 180. Okay. And then you could go through the work. You could solve for x, and then you could find the angles. If you want to kind of check this, I'll tell you what the answers are. If you want to see if you can get the work, see if you can get it right. Angle KLN is 125 degrees, and LM should be 55. So you could practice working that out. If you don't feel real confident about solving equations, then that gives you an opportunity to kind of practice solving that out if you want to. But it'd be very similar to the one we did at the top of the page. Okay, questions on any of that? Okay, you got some time here to work.